So we now have the pleasure of having Caroline O'Brien and Martin Lamb from Kubos Semiconductors, who are going to share with us the groundbreaking work they're doing in the lighting industry, in particular in the LED lighting. So Caroline and Martin, over to you.
Good morning, everybody. Thanks, Alex, for the introduction. I'll just share my screen. So it's my pleasure today to be presenting at the Mill Trust inaugural showcase. I'm joined, as Alex said, by Martin Lamb. Martin really developed the original concept for Kubos's technology, along with the University of Cambridge in 2014. It was furthered since then, and Kubos was formed in 2017 to commercialise and to further the technology. So Kubos is currently raising 2.5 million. This is to take us from early evaluation projects with customers to full commercialization through licensing and royalties. So Kubos is a next generation in LED technology. We all know today that LED lighting is very efficient and replaces the current filament bulb lights. But Kubos's LEDs can be more efficient again, by about 20 to 40%. We've calculated along with the Carbon Trust that this could save over 600 million tonnes of CO2 emissions in lighting and displays. This is as much as 150 coal-fired power station emissions in 1 year. So it's really significant savings. So what is the problem? Well, today, red and blue LEDs are very efficient. But when those technologies are moved into the green wavelengths, the efficiency rolls off significantly. This problem has been well understood in the industry, but has remained unresolved for more than 10 years. This is why when you go to buy your white light bulbs from the stores, you either get the choice of your cool blue hues or your warm candle glows. And this is because today, your white lights are actually blue LEDs with yellow phosphor coating. This is very inefficient. The absolute best way to make a white light is through what's known as a red, green, blue color mix solution. This would be the most efficient way to do that, but it would also improve the color hues so that we'd end up with a mimicking of daylight more naturally. This would have additional benefits of being able to improve concentration in offices and schools, for example. The way to compensate today is to add more green LEDs, but this adds to the costs of the full color white light solutions. So Kubos can solve this problem. So we can solve the green gap by being more efficient for green and amber LEDs. But we can also solve a second problem for displays, which today full-scale red LEDs won't scale down to the small form factors required for the new and emerging market of micro LEDs for displays. What's really key is our technology is compatible and scalable to existing production lines, and we've demonstrated this in a commercial environment already. Our initial target markets are lighting, so high current and high drive current lighting, spotlights, and runway lighting, for example, but also displays. And the introduction of the micro LEDs into TVs and AR, VR is a really exciting and developing market. So we can produce white light more accurately and mimic daylight more naturally. And we've absolutely got the right team and the core team to develop this technology. For myself, I'm the commercialization expert. I've spent nearly 30 years in the semiconductor industry, developing products for new markets and also for licensing and agreements with customers. Martin has spent quite a long time in the industry and is a veteran of the compound semiconductor industry. Until 2000, he was MD of WaferTech, and they were subsequently bought by a UK company called IQE, who's a leader in the wafer and materials segment of the market. In 2005, he left IQE and effectively has been investing and supporting businesses like Kubos since. A key part of our technology development and driving our technology is Professor David Wallace. He currently holds seats in the University of Cambridge and the University of Cardiff and spends a large amount of his time with Kubos developing our technology, along with two of the co-founders who are University of Cambridge employees, but also contract to Kubos. We also work with another couple of contractors, and one of these contractors, who is a growth expert in the industry, will join at the end of this funding round. So as I've mentioned, the market is really quite huge. As you can see here, LEDs touch all parts of our lives and can go into many different applications. But for the Kubos's next stage, we're focusing on the lighting and displays market. If we look at these two markets, they've got quite different dynamics. So the lighting market is growing at around about 12 to 14%, whereas the display market is aggressively growing at a plus 80%. Based on the share of addressable markets for these two segments, Kubos, from a bottom-up plan in forecasting, can show that we can address about 4 and 8% of this market in the 26 to 27 timeframe. So we've already engaged with a large number of LED manufacturers and leading companies. We've got 2 customers already engaged in commercial negotiations, both of which are blue chip organisation and household names. One of them is actually evaluating our material as we speak. We've quoted projects with them, and during next year, we expect our first revenue to be realised from these 2 commercial agreements. In terms of the competitive landscape, as I mentioned, for more than 10 years, the existing technology has been worked on to develop and improve the efficiency, which has had modest gains over those years, but it's not solved the problem. Kubos, with its material technology, can solve the issue that causes these inefficiencies in the green gap region. We're also aware of other developments in other technologies, which are really making good progress in the lab, but have not been able to crack the full commercialization production challenge. And those are really in still lab development stage. So the material that Kubos has today can not only demonstrate that we can solve the problem, but we can be compatible with existing production lines. So Kubos operates what's known as a fabless semiconductor model. This ensures that we keep our capital expenditure really light, and also the amount of investment required is much less than some of the other companies that are developing material technologies in other markets. By outsourcing, we can ensure we access state-of-the-art equipment, but we can also then bring in multiple suppliers to ensure that we have a good, solid supply chain. Our technology is patented. We had a grant of the patent, our core patent, in Singapore, and we've recently had a grant of the patent in the US, which is key. In terms of the financial progress as we go forward, you can see that as a bottom-up forecast, the numbers are really substantial in terms of the growth and the potential that Kubos can achieve. In terms of operating costs, after this initial investment, the operating costs remain relatively flat as we go forward and as we scale the business. And these numbers are really based on us securing the investment in the time frame that we've required, but it's a huge opportunity. So as I've mentioned, Kubos is raising 2.5 million. We've already secured over 500,000 of that first tranche that I mentioned here. So we're aiming to close that out in the next few weeks. We do have shareholder approval to go a little higher should we have some strategic investment that we want to close. The bulk of the round would close by October 2022. Currently, our pre-money is 4.08 million. With this runway, we're anticipating we would employ 8 further employees. We'd sign our first licensing agreement, and we'd also further our technical development. So today we're at 1% efficiency. You can see here one of our examples of our LEDs. The target is to be 5% by the end of this year, and at the end of this funding round, we'd be at 10%, which really changes the game for the green gap in LEDs. In terms of our exit, the plan is 5 years, and we are targeting over 100 million acquisition based on comparators that we've made with the industry. I'd like to thank you for listening, and Martin and I would be more than happy to take any questions that you may have.
Wonderful. Thank you, Caroline. So I have a few questions here. So first of all, can you explain how Kubos has been able to overcome the green gap that you mentioned where so many other participants have failed over the last 10 years?
Yeah, Martin, maybe you'd like to address that one.
Sure. So the solution that we have has been known about for a long while. Many people have cottoned onto the fact that it could do the job, but the real issue has been having a scalable technique for producing the material. And the approach that we've adopted allows us to do that. So our process and is based on standard production scale equipment for 6-inch wafers or 8-inch wafers, all standard stuff that is used in the LED industry today, and it's completely scalable. We can drop it in. We're not doing anything very different from what's done with the normal LEDs. All we're doing is producing a slightly different crystal structure, and I won't go into that because everybody's eyes will glaze over and go to sleep. But it's basically the same material, but with a fairly subtle tweak to its properties that produce this material that will allow us to do this, and we've demonstrated that it works.
Wonderful. Okay, thank you. And so you mentioned that this technology is entirely compatible with LED manufacturing today. Can you explain and elaborate a little bit more on that?
Yeah,
sure. So we're using a silicon substrate. So it's a standard vanilla piece of silicon that you can, well, clearly everybody knows about, and Matthew was talking about the chip shortages at the moment. There are shortages of silicon, but those are probably temporary. But we use standard silicon just as those chips do. And we grow gallium nitride on top of it using standard equipment that is already installed in the LED industry in significant quantities. So there's installed capacity for doing this in volume. And all of the materials and consumables are identical. So all we're producing is the same material. So it's gallium nitride still, but it has a cubic structure, not a hexagonal structure. And that subtle difference means that it has slightly different properties that allow us to make devices that are more efficient.
Okay, great. And then how many other people or groups are looking to introduce this kind of technology, and also who would be the likely acquirer of this type of IP?
Okay, so there is competition, and there are alternative approaches. As Caroline said, the industry has been working for 10 years to try and solve this problem. One thing that you can do with the existing gallium nitride structures that people are using is you can rotate the material with respect to the way the device is produced, and that in principle has the opportunity to produce a more efficient device, and people have managed to do that. So there is a subtle change to the existing technology that allows you to improve things, but you don't get the same big win that we get. In terms of direct competition for our approach, there isn't any. We have also obviously protected our intellectual property. There are people in the States who are looking at a very academic way of producing this material, but it isn't scalable. So it produces long, thin lines of the material, but they're not really suitable for volume manufacturing, whereas we're producing 6-inch wafers. So in terms of competition, there is competition, but you know we're ahead of the game, and we've protected what we've got. In terms of the likely acquirers, any of the mainstream LED producers would be interested in this. It's a problem that everybody faces, and as Caroline has said, if you go to the display market, everyone is chasing the displays market and looking for ways of breaking into that as soon as they can because of the enormous accelerated growth rates that everybody's seeing. So there are many established companies, the likes of Osram and so forth, Lumileds, Philips, all of these people are potential acquirers. And then there are other specialists who, given that we're a materials play, who would also be interested in us.
Right, thank you. And so obviously this is an incredible technology to address the energy efficiency and save on or to help on the climate change problem as well, but then also to improve on the quality of the RGB lighting solutions